And I will know when it's being live streamed in just a moment here. There we are. Okay. Make sure all the audio is off here because otherwise I'm going to get all screwed up. Okay. It shows that it's being, okay. Turn off audio. Hello, everyone, and welcome to Climate Chat. I am your host, Dan Miller, and we have co-mod here, Eli Rabbani is here. And today we're talking about the COP28 meeting going on in the UAE, United Arab Emirates, right now. And we're going to talk about whether it's being serious about climate change. And we're going to talk about that from a few different angles. Welcome, Stacy. There you go. Hi. I'm just getting all this audio stuff set up here. That was a little bit of a challenge, but I think we got it going and we're live on YouTube right now.
Awesome.
So we're talking about the COP28 meeting. A lot of attention is going into that meeting, a lot of coverage of it from various different aspects, talking about some of the accomplishments or the supposed accomplishments of the meeting, including discussing a loss and damage fund, which is meant to compensate developing countries for the impacts of climate change and to help them, deal with that. It's very, very little money compared to the damage that's being caused. And they're trying to focus a lot of attention on that because it's sort of a positive thing. But the other side of it is that there's a big discussion about whether we should be phasing out fossil fuels. What is it? Phase out or phase down? And not just phase down fossil fuels, but phase down unabated fossil fuels. And there's a lot of talk about the language, around the wording of what they're trying to do. And that's, if we take a really high level view of all of that, it's that not really much is happening. A lot of time, and if you plot out CO2 emissions versus COP28 meetings. Hold on a second. Remember, when you come on here, you got to mute and make sure your camera's off unless you're asking a question or making a comment. And so the focus, if you plot out the emissions over time and the COP meetings, this is now number 28, you just see that the emissions keep going up and the COP meetings have absolutely nothing to do with slowing them down at all. And I think this is another case of that. But this year is a little different than the other years. And one reason for that is that the head of the COP, is sort of the person in charge of this particular meeting, is the head of the UAE oil company. Al Jaber is his name. Let me see if I can, pop that. Okay, go back to Zoom and I will share the screen. And here we go. So, and then this is an article from Drilled News. And it says, once again, Al Jaber tells the world exactly who he is. So this is having the head of an oil company run the climate conference is a little bit like having the fox, leading the chicken conference or something like that. And it's so absurd that I think if you wrote it as an Onion article or something like that before it actually happened, everyone would think you were being so ridiculous that it didn't make sense. But somehow it happened. And actually, I would have loved to have been at this meeting where they approved him, because the cluelessness of the people doing this, or well, maybe it's not cluelessness, it's influence, it's money, it's a lot of other things, obviously, that went into this decision. But he made a bunch of, Al Jaber made a bunch of comments before the meeting and supposedly used the fact that everyone was coming to the COP meeting to arrange some meetings to discuss oil production with other countries. Like, how can we make a deal together to increase oil production? And so that leaked out and caused some problems. He also made a comment that I don't think he really meant, and this article talks about that, where he said there isn't any science that says we need to phase down fossil fuels, or we have to eliminate fossil fuels, I should say. And he actually tried to correct himself right at the moment he said science. He said, I mean, scenarios. And as this article points out, he's correct in that the IPCC scenarios all assume that fossil fuels will continue. And that's why they also use negative emissions technologies, carbon capture and the like, to offset that. And so they're suggesting, well, they're not saying it, but implicit in what they're doing is assuming that we can use carbon capture to offset fossil fuels. And that, of course, gets a lot of criticism. In fact, I don't know, tell me, did this switch? Can you now see the New York Times, carbon capture won't save us from climate change? Did that switch on Zoom? Stacy or Eli?
Yes, yes, sorry. I was trying to space bar that it tells.
All right, good. I just want to make sure what I'm doing here is working here. Okay. So as this is an example of a recent, Eli needs to come in here. Somehow he got kicked out. Okay. So this is a recent op-ed, or actually opinion piece in the New York Times, December 8th, 2 days ago, saying carbon capture won't save us from climate change. Now, if you read that headline, it sounds like carbon capture isn't any good. If you actually read the piece, it doesn't say that at all. It just says what we shouldn't do is rely on carbon capture to allow the continued use of fossil fuels. And that is true. We shouldn't do that at all. We should be phasing out fossil fuels as quickly as possible. And however, I also, and actually I wrote a letter to the editor on this one, pointing out that carbon capture, another headline would be, which would also be correct, is we don't meet our climate targets without carbon capture. And when you put it that way, it takes on a whole different meaning. This one makes it sound like carbon capture, it certainly won't save us on its own, and it certainly won't save us if we use it as an excuse to continue to use fossil fuels. Sure, of course. But if we actually finally get serious about climate change, and I guess if we take sort of what is the high level overall theme of today's the climate chat, it's that we have yet to take climate change seriously. We're not doing it now. And the IPCC, and I think a possible, and this is, I don't know if this is true, but a possible positive outcome of COP28 is that people will realize that no one is doing anything about climate change. The COP meeting is going to end without any serious action on climate change. There'll be some words around increased ambition and things like that, but obviously having a fossil fuel company in charge, there won't be any serious calls for elimination of fossil fuels as quickly as possible and that kind of thing. And if people realize that, oh, wait a second, these guys, they're not really doing anything. They haven't done anything over 28 years. And now it's getting really obvious that they're not doing anything. And if they understand that, and then they understand that the national governments, with a few maybe exceptions along the ways, but some Scandinavian countries and things like that are starting to get serious, that for the most part, there's no real action plan to solve the climate crisis. Carbon capture would be, and as we've talked many times, and I'll just repeat it here, especially for anyone who might be new here. The three legs of the stool that we need to fight climate change are: one, to get our emissions down to as close to zero as quickly as possible. And that means eliminating fossil fuels from everywhere where it's humanly possible to do today. Use carbon capture for those, like things like cement, that we're not going to eliminate cement production in 5 years and hold off for 30 years before we have green solutions. So things like that, use carbon capture for these industrial emissions that you can't get rid of, and then start to scale up direct air capture to take CO2 out of the atmosphere. Start to scale it up now. It's going to take time to do that. As I pointed out in this letter to the editor of the New York Times about this piece, carbon capture today is about, in terms of the volume of it, is very small today. And it's on par with what solar photovoltaic energy production was 30 years ago. I mean, it existed, solar PV existed 30 years ago, and you could buy it and everything, but it's very expensive. And the amount actually used for energy production beyond specialized applications, like a sign out in the middle of nowhere, there's no electricity running to it. So
I just need to add that I think it was 1985, there was a solar home built in my Podunk 2-stoplight town in the middle of nowhere, Pennsylvania. And it was, it seemed almost like space age stuff. I doubt that there has been, it was probably another 30 years before anything solar was built there, but that one existed.
Sure. And I have, from the 1970s, I have this catalog of, back before the internet, electronics companies had to produce little catalogs of all their parts, integrated circuits and things like that. And there was one, I think it was called IR, if I remember correctly. They made solar cells, but these things were really expensive. You bought, like a little 2-inch thing. And what they did is they made, I think, what was the world's first solar panel. They made what looks like a solar panel filled with solar cells. It must have cost millions of dollars for that one panel, because each cell was super expensive back then. And they put it on top of an EV. Of course, they didn't have regular EVs, so they put it on top of an EV from like 1912. It was an old looking car, but it had an electric motor, because people don't know this, but EVs were actually quite popular around 1910, and before gasoline cars took over, which was a shame. So this was one of the first solar powered EV. It was anyway, but it just shows that it's been around. The technology has been around for a long time. Carbon capture, by the way, has been around for like 50 years. It's been used in industrial processes at small scales for a very long time. But using it to actually lower the CO2 content of the atmosphere is a whole different world. And that needs a scaling very much like what solar PV has gone through, where solar PV is now making a big contribution to our energy needs, where, even 10 years ago, you wouldn't say that. And again, 30 years ago, you would have laughed. People would have laughed at you if you said, oh, this is going to make a big impact on our energy needs, because they just couldn't imagine it scaling up. So we need to get direct air capture scaled up. Now, that doesn't mean it's going to be capturing a lot of CO2 in the near term, but we're going to learn how to scale it up, just like we learned how to scale up solar PV. So that's the second. So first thing, get our emissions down as to close to zero as possible. Use carbon capture to both eliminate any remaining industrial emissions. That's called CCS, or carbon capture and sequestration, also called point source carbon capture, because you're getting the CO2 from a concentrated source like a cement plant. And then you're also going to need to do direct air capture, which is taking CO2 out of the atmosphere. That's the second leg of the stool. Then the third leg is to use sunlight reflection methods, or what's also called solar radiation management, to reflect some of the sunlight away, so we can cool the earth while we work on the first two things. And so in addition to the articles here, let's see, how do I do this here? Jim Hansen also wrote a letter, kind of like a paper, but it's not a peer-reviewed paper, but it has lots of references, and he just published this. And this is talking about essentially COP28. So he was going to go to COP28, which is why he said, Dan, I can't do an interview with you until I get back from COP28. But what talks about in this letter is they were trying to get him to give a talk there, but he's sort of persona non grata over there, because he just came out with a paper the pipeline paper, which we have discussed extensively here on Climate Chat, which says the IPCC is wrong. And both the warming from greenhouse gases is much higher than what they say. In this case, the IPCC says a doubling of CO2 would, without, just on its own, would lead to 3 degrees of warming. And Jim Hansen says, no, it's 4.8 degrees of warming for a doubling of CO2. And on top of that, in addition to that, so step one, the actual warming from greenhouse gases is much higher than the IPCC assumes. And he also said that the cooling from aerosols, or think of that as smoke from ships and coal plants, that's called aerosols, which are fine particles in the atmosphere. And they both reflect the sun away, but more importantly, they actually form the nuclei for water to condense to clouds, so to form clouds. And not only do they form the clouds, they make them brighter and they make them last longer. So that's the big effect of this pollution, is these aerosols, but they also reflect the sun directly as well. So Hansen is saying, and it's in the pipeline paper, that the cooling from aerosols is also much bigger than what the IPCC says. And so if you take those two things, the warming is more and the cooling is more, you can imagine why you would end up at the same temperature. Like the temperature today, we're at 1.5 C right now, roughly for the year. It's actually a little higher now, but I mean, the year, including the 6 months of relatively cool time at the first 6 months of the year. So if you take that 1.5, the Paris Agreement might say, well, it's like 2 degrees of greenhouse gas warming minus 0.5 degrees of aerosol cooling, and that gets you to 1.5. And I'm making these numbers up here. These are not like official IPCC. This just give you the idea of what's happening here. But Hansen is saying, no, it's like 3 degrees of warming with 1.5 degrees of cooling. And that also gets you at 1.5. And then you might ask, well, hey, why does it matter? We're both at the same temperature. Yeah, okay, they use different calculations, they have different numbers, but the result's the same. So why does it matter? Well, the reason it matters is because we're cleaning up the aerosols. They're bad for people's health. It literally kills millions of people a year. And when you see those pictures of China and you can't see across the street because it's so smoggy, that's killing millions of people. And so China, for example, is cleaning up its coal plants by putting sulfur scrubbers on those coal plants, something we did in the US, I think in the 70s, to fight acid rain. And so China's catching up and doing that. And then the International Maritime Organization did what Hansen calls an unintended experiment by banning high sulfur fuels in ships, starting in 2015 with a more strict rule coming into place in 2020. So all of a sudden, the amount of sulfur over the oceans where these ships were going dropped dramatically. And that caused a big drop in cooling, which resulted in a very strong warming. Now, the IPCC and all these scientists say, wow, look at all this warming. We have no idea where this is coming from. And Hansen's saying, well, of course we know where it's coming from. Look, we did the experiment. We said that cooling is more than you said. And therefore, it ends up, when you lower aerosols, you're going to get a big upshot in warming. I believe in this paper here that we have in front of us, it says that the cooling from the aerosols, as Hansen puts it, is from this drop from the shipping. So the IPCC said it would be a tiny drop, and Hansen's estimate is that it's 10 times more than what the IPCC assumes. So we're not talking about, Hansen's off by 20% from the IPCC. He's saying the cooling effect of that change is 10 times more. So these are really big. Now, so here we are. It's 2023. Warming has accelerated incredibly in the last year. And there's two big causes for that. One is that we had this rule for the ships to kick in 2020, the strict rule. And you say, well, wait a second, why didn't it get super warm in 2020? Well, it was getting warm. In fact, it was, I believe 2020 was the warmest year on record, but part of that was because of COVID and the fact that we, had a lot less, because everyone was indoors and not doing stuff. There was a lot less aerosol pollution overall, not just ships actually, but overall. And that also caused a blip of warming. However, back then it was still we had a 3-year La Nina, and a La Nina is an ocean pattern that helps cool the atmosphere. So even though this warming was kind of occurring and building up, it also was hidden a bit by this cooling pattern. Now in 2023, the cooling pattern switched to an El Nino, which is an ocean pattern in the Pacific that ends up heating the atmosphere. So no longer was it holding it back, and we had this extra warming from the aerosol reductions, including China cleaning up its stuff. But supposedly, and this is an interesting point that Hansen made in another writing, that he doesn't think that, why didn't the warming just happen so much over China? Why did so much of it happen over the oceans? And he thinks that's because there's so much other pollution in China that it has, like, even though you got rid of these aerosols, there were a lot of other aerosols there to form clouds, reflect the sun, and do all those things, where the ocean is kind of pristine. If you get rid of the ships, there's nothing else there to cause aerosols, right? There's nothing, it's just water. So when you make a change by eliminating all the clouds and the aerosols that reflect the sun from the ships, all of a sudden you have a huge difference in cooling. So anyway, so there's all this is happening. Hansen's article matches what we're seeing. It explains what we're seeing. But the IPCC does not. Their scientists say, wow, it could be, random variations and things like that. And as Hansen points out, we will know next year who's right, because he is predicting that May of 2024, coming up very soon, is going to be 1.6 to 1.7 above the pre-industrial temperature. And if it is, it's basically saying the only way you can get there is if we're right. Because the El Nino, you say, well, it's an El Nino. Yeah, but an El Nino only adds 0.1 to 0.2. And we were at 1.2. So if it was just an El Nino, you would get up to maybe 1.4. You could argue 1.4, but not 1.7. And so he says that the difference between that 1.4 and the 1.7 is these aerosols and the fact that there's really more warming out there from greenhouse gases than is being assumed. And we had more cooling from the aerosols. And when you get rid of the aerosols, you expose the fact that the greenhouse gases are really warming us up a lot. So that gets back to the COP28. They didn't let Hansen come. They didn't accept his paper. Like, they're not using his paper. To be fair, there's timelines, and it's not until the next assessment by the IPCC that they could take that into account. But they certainly could invite him to give a talk on his paper and explain why he thinks this is the way things are. But of course, it's embarrassing to many of the climate scientists there, and to certainly, even forget the climate scientists, to the leaders of the COP, who, what is their goal? Their goal is to make it look like there's progress, to show good things are happening. Having someone come in there and saying, by the way, all the assumptions you made about the climate system, and for all your very little action that you are doing, that's all wrong. And actually, things are much worse than you're saying they are, and therefore we need much more action than what you're doing. They don't like that. That doesn't fit with what the messaging they're trying to get. So he wasn't invited to do that. I believe he stayed home, by the way, because of that. And anyway, we'll find out more next week when we talk to him. Yes, Eli.
There are different reasons that they don't want to talk about these things. Part of it is those who want to slow walk ending fossil fuels, right? Because if we're making progress, then everything's okay. So there's no reason to rush. But then the other one, and I think this partly captures, Michael, the reasons for Michael Mann's kind of unfortunate stances is that, well, if we make things look, any worse, then people will lose hope, and then we won't be able to do anything if people have lost hope. And the problem here is that you can only solve the problem that you understand, right? If you're trying to do something about it. And this approach leads us to set targets which are wholly inadequate and stick with strategies that are wholly inadequate. Certainly, well, even for just what's the modal expectation, but especially for avoiding the tail risks, which are the real things that could potentially end human civilization as we know it.
Right. Yeah, they don't want to talk about that. Yeah, no, I think that's a good way to put it. And speaking of things that we're not really facing up to reality here, this is a chart, if you can see on Zoom or on YouTube, sorry, Clubhouse, but if you're in Clubhouse, you can go to the link to the Hansen paper, the PDF, and it's figure 1. So you can just see that yourself if you're listening in on Clubhouse or on some podcast somewhere. So this is the change in forcing over the years, each year. And you see that there's this big red, say the forcing. The forcing is the thing that pushes climate change. A forcing is what causes the Earth to warm. If it's a positive forcing, going to make the Earth warmer. If it's a negative forcing, it will make it cooler. And this shows that CO2, which is the light blue at the bottom, is, obviously the biggest thing. But there was, for a while, there was this red area, which is MPTG, OTG. These are the fluorocarbons that were causing a problem with the ozone hole. And then we passed the Montreal Protocol and got rid of them. But they were also super powerful greenhouse gases. And as you can see, they were really, causing a big amount of warming. And then they kind of went away because of the Montreal Protocol. And now they're a very small part of everything. The dark blue is methane, and you can see that it got smaller for a while. Again, this is a little deceptive here because this is the change in each year. And so this kind of tells you where you are, and it's supposed to be going down, but it's still going up. And you can see at the top where it says gap, 0.30 watts per meter squared. The top red line there, it says RCP 8.5. That's the worst case scenario that the IPCC uses in modeling. Now, this is sort of one, if we kept burning as many fossil fuels, kept burning coal, keep accelerating, that would be the worst case. How bad could it get? That's what that's supposed to be. And everyone says, oh, that was crazy. That was such a worst case. That would never happen. Why even talk about it and all that kind of stuff? But when you look at the actual climate forcing, you see this is not emissions, right? The RCP 8.5 is also an emissions scenario, assuming a certain amount of coal burning, a certain amount of oil burning. But this is the result of whatever, and it shows that the actual greenhouse gases, the forcing from them, is very close to that 8.5. So it's very close to the worst case, far above the 4.5 case that's supposed to be sort of the moderate case, and the 2.6 case which would theoretically keep us under 1.5 degrees of warming, but that's not true anyway. So I just wanted to show you that, just to show that the reality, this is like, this is measured stuff. This is not like, the yellow is predicted, of course, but up till now, it shows that we're tracking along the worst case. And he talks about the 4.8 degrees plus or minus 1.2 C, which is that's the climate sensitivity. That's if we double CO2 which we effectively have. We've increased CO2 by 50% in the atmosphere. But if you add up all the other greenhouse gases, the total greenhouse gas forcing is equivalent to 2x of CO2. And we're not at 4.8 degrees C of warming yet, thank God, but it takes time for that forcing to show itself. And I think what it says in here too is it takes about 100 years to see 60% of it, if I'm not mistaken. So it does take time, but it shows where we're heading. There is go ahead.
But all of that, the longer time frames, depends on the assumptions that are being made about amplifying feedbacks, and there's a lot of uncertainty about them. And again, it's this is a 2/3 chance of not having really bad climate change good enough, and by the way, we've actually missed that? Or do we care about there being a 99.9% chance that we avoid really bad things happening? Right? Two totally different things. And if you care about the latter, which I think most sane people would if they had the opportunity to think it through, you would want to be really, really sure. And therefore, the uncertainties about the amplifying feedbacks are a big problem. And the best solution is just not do the experiment.
That is true, but we're doing it. And this paragraph really stuck out at me here. So Hansen says, our pipeline, the global warming and the pipeline paper, our pipeline projection of peak warming of 1.6 to 1.7 degrees Celsius in mid-2024, next like 6 months from now, is based on the observed doubling of Earth's energy imbalance. An alternate derivation based on aerosol forcing of 1 watt per meter produces 0.3 to 0.4 global warming by now, with El Nino raising global temperature 0.1 to 0.2 above the trend line, and aerosol forcing adding 0.3 to 0.4 to global warming. We would project 12-month mean warming of 0.4 to 0.6 degrees above the trend line in May 2024. This includes the possibility of warming slightly above the 1.6 to 1.7 range estimated. He said, regardless, if global warming exceeds 1.6 degrees level, it provides strong confirmation of global warming acceleration. In other words, if we see 1.6 degrees of warming in May of 2024, he's saying we're right and you're wrong, I guess. And he's saying that particularly to Michael Mann, which he addresses at the end of the paper. Actually, there's a bunch of people. Actually, while we're on it, why don't we jump to that, because I think it's kind of funny. Okay, he also is trying to raise money for his group, and so if you're interested in that, please get in touch with him, or you can get in touch with me and I'll put you in touch with him. They are looking for funds. In fact, one of their key scientists is retiring, and they want to hire someone else and have 2 people at the same time so they can kind of hand it off. It's Makiko Sato, who's done amazing work, all these incredible graphs of temperatures and everything like that, and she's done an amazing job. So okay, so here's and Eli, you'll be interested in some of these because it regards Zeke and everything. It should be sufficient to respond to the main comments of Zeke Hofstadter, Michael Mann, and Johan Rockström. They are all outstanding scientists and exceptional communicators. Let me start off with that. Zeke commented that Hansen's pipeline paper was, quote, out of the mainstream. And Hansen writes, you're right. That is a correct summary. We used well-founded paleoclimate data to infer that equilibrium climate sensitivity is much higher than IPCC's best estimate. Also, we use multiple lines of evidence to infer that the negative aerosol climate forcing is larger than IPCC estimates. High climate sensitivity and declining aerosol forcing are the reason for the shocking increase of Earth's energy imbalance, and thus the acceleration of global warming that is now underway. So Zeke said, Hansen's that's out of the mainstream. So you're exactly right. I thought was an appropriate answer. Johan Rockström, in contrasting his view of the situation in mind, notes that global fossil fuel emissions declined 7% in the first COVID year and suggests that a similar reduction every year would largely deal with the climate problem. I don't disagree with that, but no energy expert I have met believes that such a rapid reduction is plausible. And the West has no right to demand that nations working to raise their living standards reduce their emissions 7% per year. Also, I note that our data only shows a 5% drop of emissions in the COVID year, not 7, that was new information to me. And then he talks about Michael Mann. So Michael Mann was saying things that I just couldn't believe, because he was saying that if we reach net zero by 2050, we could stay under 1.5 degrees when we're at 1.5 degrees right now. So, I mean, to me, that was weird. And I really don't understand it, to be honest with you. But anyway, Hansen writes, Michael Mann says that he doesn't see any acceleration of global warming. Okay. Some people would say that the acceleration is already apparent, but the level to which global temperature rises by next May and then falls in the next La Nina will firmly settle that matter. So he's basically saying, let's go see what happens next year and we'll see who's right. Anybody want to take some bets?
Yeah, so the Johan guy is the one that is, this cracks me up. So in the first COVID year, we had effectively 3 to 6 months where everything stopped.
Right.
There weren't, I mean, the wildlife came back. You could hear the birds. Everybody's at home. Things are shut down. We don't know what we're going to do. Oh my gosh, like, and out of that, we got 5 to 7.
Well, 5 to 7%
reduction. It is you're gonna die if you go outside. Don't do this for the entire world. And we went down.
By the way, that was only the first 5%. Or 7. Let's be generous and call it 7%. Okay.
Yes, sure. 7.
You then have to do it again. Not also, you have to take everything you did and you have to do twice as much now.
Yes.
You have to get the next 7, but you can't give up on that first 7%. You have to keep that, do everything you did to get there, and then do it again the next year, even more. You have to double it and then triple it, then quadruple it, then every single year.
What he is saying effectively is he is looking for Thanos to save us.
It's when pigs fly, we'll be fine.
No. Well, the Thanos is the
destroy everything. Yeah, right. Yeah.
Well, half of the world is gone with the snap of a fingers. That is the only way you could do year over year reductions is by, well, you don't have to do half. You could do, I'd say 10 to 25% of the world's population is gone.
Well, but if you do it that way, you'd actually have to get to 100%, right? So that would mean everybody. So maybe there are better ways. Maybe instead of like killing everyone, maybe instead, just a thought, maybe we should phase out fossil fuels and replace them with clean energy. That might even be a better way. Then you don't have to kill everybody. I would suggest that we give that some thought.
Sure.
And then also, if we did carbon capture to eliminate the emissions from those things that really we're not going to get around to eliminating in 10 years. And hey, just a thought, we know that putting particles in the atmosphere cools the earth and doesn't kill everybody, because it happened in 1991 with the Mount Pinatubo eruption. And by the way, which shows very clearly on one of their graphs here in this paper, like, wait, why did all of a sudden the CO2 emissions drop so dramatically? And that was because the earth cooled so much. And you remember, heating also gives off CO2, right? When the earth is warm, it gives off more CO2 from various sources, from the oceans and plants and land, oils and things.
If we're lucky and it doesn't give off a lot of methane.
Yeah, that's true. But anyway, so in 1991, there was the amount. So I think we went up 3 parts per million last year. By the way, speaking of just some dramatic, here's, you go to co2.earth. It gives you what the current CO2 level is in the atmosphere on Mauna Loa Observatory in Hawaii, which I've been to, by the way, which was very cool place to go. That number is crazy. 420 parts per million. That is sort of exactly a fifth. I mean, from as close to the estimates we have, we think the pre-industrial CO2 level was 280. Half of 280 is 140. Add 140 to 280, you get 420. So that means the CO2 level in the atmosphere is now 50% higher than it was in pre-industrial times. And that's right now. Actually, I could refresh it because this is yesterday. I think I opened the page, but still, yeah. Anyway, it's going to be the same.
And just a little history, going back to Svante Arrhenius's observation that more carbon dioxide in the atmosphere will lead to warmer temperatures. He took the case of doubling CO2, and that's kind of been established as like what you describe as climate sensitivity. And when you factor in the other greenhouse gases like methane, we're essentially at that doubling.
That's correct. I mentioned that earlier. Now, one thing to be careful of, and by the way, the last time that on Earth that CO2 was 420 parts per million, sea level, and this was millions of years ago, by the way, it hasn't been this much CO2 in a very long time. It was millions of years ago, and sea levels were about 75 feet higher than they are now. Now, so that's where we're heading if we keep this. Now, the 420 will not remain. There's almost no chance that it will continue at 420. For now, we know it's going to go up. And why? It's because we're continuing to burn fossil fuels at, by the way, a record rate. Okay, at a record rate. And that's going to increase. But if we did stop emitting CO2, then the atmospheric CO2 concentration would hopefully go down. And I say hopefully because that assumes we haven't crossed a tipping point of like permafrost, adding more CO2 each year than we decrease our CO2, right? I mean, but it's putting that aside, hoping that's not true, then the oceans would continue to take up CO2, even though we're no longer emitting it. And everyone, even I thought this way. You think that, we're emitting this much this year, and the oceans take out a percentage of that. It actually, it does take out a percentage of that, but it's not because the oceans have no idea how much CO2 we put up this year. The only thing the oceans can know, if you quote around know, is how much total CO2 is in the atmosphere versus how much CO2 is in the oceans. And so the moment, if we just snapped our fingers, and today, at the moment, we stopped emitting all CO2 emissions, the oceans would continue to absorb CO2 at the same rate it did yesterday. It wouldn't know any difference. It just knows there's this much CO2 in the atmosphere, this much CO2 in the oceans. There's too much CO2 in the atmosphere. I'm going to keep absorbing it into the oceans. And so that would actually lower CO2 over time. Now, it turns out that there's also warming in the pipeline, which is what Hansen's paper is about. And so even though CO2 would be dropping, the temperature wouldn't be dropping. And the reason for that is that there's still some warming in the pipeline that we haven't experienced yet, just from the emissions we've already made. And so it would be, those two things sort of counter each other. And that's why scientists think that if we did turn off all emissions tomorrow, which is, by the way, that's not a real thing. That's just what's called a scenario. It's a way, if you want to analyze some scientific data, you say, what if we shut off all emissions immediately? And it's not gonna happen, but that's something good. Anyway,
Dan,
so we're getting a bunch of people entering the room. Yeah,
Dan,
go ahead.
A question. So, and I think I've asked this before and cannot remember the answer. We know that it's bad. That's why we stopped it. It's bad for human health. It's bad for marine health. It is, one of the Faustian bargains, the ships polluting. What is there a solution that is more palatable than turning it back on or sunlight reflection methods, which gives
Well,
everyone
that is
a
what
pass
sunlight reflection methods
unnecessarily.
is. Yeah, that's exactly what. Remember, I mean, using ships and putting sulfur in the atmosphere from the ships is sunlight reflection methods. It's not sort of like it. It is. Now,
Gotcha.
the only difference between it and other and the on purpose one is the fact that it was accidental versus on purpose. You know, scientifically, there's no difference. But however, it's a very bad way to do it because the particles you put in the atmosphere only when you do it from a ship or from a coal plant, only last in the atmosphere for about a week. And then they fall out. They're near, you know, they're lower atmosphere. They just fall to the ground. They're, you know, kind of heavy and they fall to the ground in about a week. But if you put them in the stratosphere, the same particles, but put them in the stratosphere, they last for about a year. So you can reduce that pollution, that damaging health pollution. You could reduce it by 95% and take the last 5% and put it in the stratosphere. And you'll end up with more cooling than the 100 million tons of sulfur that we pump into the atmosphere every year. And the only reason it's acceptable is because it's by accident. There was somebody, and I met this guy, he put a few grams, and I mean grams, not kilograms, not tons, a few, like a spoonful of sulfur in a helium balloon and released it in the atmosphere where it would rise up to the top near the stratosphere. And then finally the low pressure would pop the balloon and the sulfur would be in the stratosphere. And this is only purely symbolic. There's like no real effect from literally a teaspoon of sulfur, you know, up there that high. You couldn't possibly measure it. They're not, you know, it's just a symbolic act. And in fact, I saw him at a conference where he was giving out balloons so you could release them and do your own solar radiation management. But this caused all kinds of people to go, oh my God, look what he's doing. This is horrible. This is terrible. And Mexico, he did it, I think, in Mexico. Mexico banned him from doing it. And everyone is like banning, you can't do this stuff. At the same time, every year, we're releasing 100 million tons of this stuff, which is killing about 8 million people a year. So it's like, it's, you know, this is just a crazy world we're in, right? I mean,
So
we're doing this one thing, no one cares.
Paul mentioned in the chat that it's the EPA and other environmental agencies that won't allow it. It's a violation of clean air regulations across the world. So I guess that's something that would need to be tackled, is to address.
But again, to be super clear, we're talking about a process where you would lower the pollution by 95%. So if you're going to argue that it's not okay to, the only difference is you're doing it on purpose to cool the earth. And I thought, so I realized the way we can get around this is that I'm going to start a company that's an advertising company.
Yeah.
And I want to promote my climate chat podcast. So I'm going to write climate chat podcast in the stratosphere. And I'm going to use sulfur particles to write this message across the stratosphere. And because since I'm doing it for advertising purposes, that's my main goal. The fact that it happens to cool the earth at the same time, no, that's okay. All right, that's acceptable. Just like a ship that gives off CO2 because it's trying to sail, you know, across the Atlantic. The purpose, it's cooling the earth, but it's not doing it on purpose. It's doing it to sail the ship. So as long as you don't do it for the purpose of cooling the earth, then you can do it. We'll see if you think that'll work.
Well, so
Let's do it.
Paul said, I've sat in meetings with EPA regulators who have specifically said they will not issue emissions regulations to any companies that propose these measures. It's a violation of all of our regulations that have been in place since 1971. And that sounds about accurate. The issue is what's happening is is worse. And I don't know how to get around we know ship smoke bad, and we know earth heating up worse. How do we?
Oh, there is a group, and I saw it is on this what a Google group thing I'm on, where they're passing around this letter that they want to get everyone's signature on, asking the International Maritime Organization to temporarily reverse their sulfur regulations for ships because of the warming it's causing. And I'm saying, once you do that, once you have them increase the sulfur, that is intentional solar radiation management, right? You're not doing it, you're not increasing the sulfur to help the ship sail anymore. They're sailing just fine without the sulfur. You're adding the sulfur for the purpose of cooling the earth. You're doing a terrible job, by the way, because you're releasing the sulfur in the lower atmosphere where it lasts for a week. So you need tremendous amounts of it to cool the earth, where you could take a tiny bit of it and put it up in the stratosphere and it would cool the earth even more. But so this is intentional solar radiation management in the guise of please reverse your ruling that you just made.
But
So we live in a very bizarre world, but here's my prediction. My prediction is, for first of all, as we are all talking about, governments, regulatory bodies, environmental groups, many groups are totally against SRM, sunlight reflection method, solar radiation management. Solar geoengineering is another phrase for it. Totally against it, think it's a terrible idea. There are some groups that want to ban not just doing it, ban research into doing it. I mean, that's pretty crazy, by the way, when you start talking about that. But that's that, and I agree that that's the way it is now. And I also guarantee that we're going to do it quite soon. By quite soon, I mean ramping up to maybe only start off with a small amount, but ramping up to do it within like a decade. And why are we going to do it? We're going to do it because, as the Hansen paper in front of us says, global warming is accelerating. We're at 1.5, and we didn't talk too much about it, but we're at 1.5 degrees right now. And he's saying it will drop to 1.4 after the next La Nina. It's going to drop below 1.5. But it said once it drops a little bit below for a La Nina and goes above for an El Nino, that's when you're at 1.5. That is 1.5, right? It's, the trend, the middle line. So you're below and above, below and below. Sorry, it didn't come out clearly. Above and below. And that means you're at 1.5. So we're at 1.5 right now, on our way to 2 fairly quickly, because remember, as Hansen's pointing out in this paper and in the pipeline paper, the rate of global warming, how much it warms per decade, is up at least 50% from what it was since 1970 to 2015, which was 0.18 degrees per decade, about 0.2 degrees a decade. And now he's saying it's at least 0.37, 50%, but might be double, might be 0.3 something, 3.6, I think. And so we're going to reach 2 degrees much sooner than we thought. And since we're now at 1.5 and now we're going to be above 1.5, plus or minus going next few years, the shit is going to be hitting the fan. We've seen it in the last year. We've seen things we've never seen before. 30 inches of rain in Italy in like 24 hours. I mean, 2 inches of rain is a lot. 30, it's absolutely insane. And no infrastructure can handle that. We don't have storm systems that can handle 5 inches of rain, let alone 10, 20 inches. And so we're going to see so much destruction. We're going to know what's happening. We're going to see the tipping points, especially. We're going to understand the tipping points. Oh, by the way, oh my God, let me tell you this exciting stuff about climate chat. Next week, we have Jim Hansen. I still to double confirm with him, but he did say December 17th. January 7th, we're having Peter Ditlevsen, who wrote the AMOC paper that we talk so much about. He's the Danish researcher that wrote that AMOC collapse paper. My brother, who's, by the way, I'm here taking care of my dad, who's ailing, and my brother's from Denmark's coming in later this afternoon. He met him at a conference because he's, there's Denmark. And so he hooked me up with him. And so we're going to do an interview on January 7th. And I know Stacy's going to be excited about this. On January 14th, so the week after Peter's interview, we have an interview with Johanna Volhart. Johanna she might go by Johanna. My friend spelled the same as Johanna, so I don't know which one she goes by. But she's the woman the scientist I met on the climate march in New York, who's doing research on how protests can affect public policy and things like that. And she said, actually, like the week before this interview, she's going to go to a conference where they're discussing specifically about climate protests. So she'll have all that information with her as well. So that's the upcoming. So it's going to be, we'll do shows over the holidays as well, but there'll be the open discussion like we're doing today. But we have Jim Hansen, December 17th, Peter Ditlevsen, I got to make sure I pronounce his name, Ditlevsen, on January 7th, and Johanna Volhart on January 14th. If you want to look up Johanna, her last name is Volhardt. And so this is going to be a very exciting upcoming month for interviews here on Climate Chat. Yes, Stacy, looks like you want to say something, or I'm not sure.
Yeah, I did. And Dr. Brian has been patiently waiting as well.
Oh, yes, we're going to open it up now too.
Yeah, my question back is and again, I am all about the more direct, like I cannot stand the contortions that we do to try and keep the status quo and everything humming. It's like I'm willing, it's like we need to make drastic change and we should just do that. Having said that, and what Paul had put in the chat about how and what we know that everyone is allergic to sunlight reflection methods. Is there a way, much like we removed lead from gasoline, or we, that we could make the fuel, because they're using that filthy bunker fuel, whatever, they've changed the fuel. Is there a way to have an additive, give the oil companies something to do, that would retain the sulfur, but not all the other noxious stuff? Or is it just like, no, that's it. The only thing we've lost.
Well, yeah, the sulfur in the lower atmosphere is bad. I mean, it's bad for your health and it's just not good stuff. Reducing it by 95% and putting the rest in the stratosphere really would improve health and improve cooling at the same time. So I don't think there's.
So why are the scientists, why they, so Paul had also said that, it's because of environmental sensitivities, that this is bad. We cannot, we don't want to disturb, these fragile ecosystems with this stuff that we've been doing forever, and now as you've mentioned, we need a much smaller amount if it goes up higher. Why can the scientists are they unable to show, look, it is way less bad to do this, like the good that comes.
Well, there's very little. We had Doug McMartin on. I saw him pop up into the clubhouse room. I don't know, Doug, if you're here, grab that Zoom link in the clubhouse room. By the way, I should say, if you want to join the conversation now, we're going to open it up. You need to go to Clubhouse and join the Climate Chat house. You will then be able to join the Climate Chat discussion, which is we're streaming this YouTube Live to Clubhouse. So we're not really directly interacting with the folks on Clubhouse, but if anyone who does want to join the discussion, and if you're in Clubhouse right now, you'll see a Zoom link at the top of the room, and you can click on that and join the Zoom. That's where we're going to actually have the discussion. This Zoom is being streamed to Clubhouse and to YouTube Live right now. And then it's available, by the way, after we're done, obviously as a recording in Clubhouse, which is hard to access and whatever, but you can go to the Climate Chat homepage on YouTube and you can listen to past recordings. All of the YouTubes that we've done in this new format on Zoom and everything, they're all available to listen to past recordings. So that's going to be good. Going forward, all our recordings will be available for replay on YouTube Live. Let's see, I don't know if I really answered your question, but the answer is it's a good thing to get rid of the sulfur from ships. We did it, and it's a good thing that China is doing it. I mean, it's really literally killing millions of people. It's not a little thing. But there are better ways. And by the way, putting sulfur in the stratosphere is one way to do it. But just for everyone's benefit, and maybe who's new here, there are other ways to cool the Earth. One way is to put mirrors on the ground, paint everything white, reflect the sun as much as possible. I don't understand how that gets to scale without, covering literally the entire United States with mirrors, or I mean, an area equivalent to the entire United States. But there's a group called MEER, MEER. I guess it's MEER.org. I'm not sure what the URL is. They propose that, and we should get someone on there to explain it. I mean, to interview somebody to explain it to me, because I don't understand how that works. But there are people that think that would work. There's another way to do it,
Just
and that is
a quick mention.
Eli.
I mean, that can make a real difference for the urban heat island effect if you do it in cities,
Sure.
right? Because
of course.
And that
planting trees cools the cities, painting roofs white. It's a good thing to do. Don't get me wrong. I think it's a good thing to do. I just don't think it changes the 1.7 C of warming that we're going to experience.
Well, it does.
Although
locally.
it could help take off the edge in the cities where it won't be 1.7. It'll be 2.5 or 3 degrees of warming, and it might take the edge off there. Yeah, Dr.
Just look at the marine clouds in Los Angeles. It's 20 degrees cooler when that happens. And isn't the IMO letter really focused on, international waters that are outside the exclusive economic zone? So the EPA does not have jurisdiction.
Yeah, but what everyone else did already before this other thing is they already passed rules that you weren't allowed to use bunker fuel within those. You had to switch to a clean fuel anyway, which I guess is why the IMO could do it, because all the ships already had to have a way of sailing into port without giving off all that smoke. So I think that, I think those rules were already in place for the local stuff already. But speaking of the clouds, okay, because you brought it up, marine cloud. So again, I don't understand. I mean, it is proposed that the mirrors would do it at scale, whatever that means. I'm not sure. Another one that is proposed is to actually called marine cloud brightening. And this would mean you sail robotic ships over the oceans, and they take seawater and spray it up through smokestack. Well, not really smoke, but through pipes way up as high as they can go, I guess. And they kind of pulverize the seawater so you can expose the salt crystals into the atmosphere. And they can, and water droplets in the atmosphere can condense around it, and basically you create clouds. So it's a ship going around, spraying seawater into the sky to try to create clouds. And if you do that, and you certainly can not only replace the aerosols caused by shipping, the sulfur clouds from shipping, but not only replace them, but expand on it, so it's actually far more than that. You can get a lot of cooling if you can do that. So that's another way to do it that doesn't involve pollution, sulfur pollution. It's just spraying water up in the air, and hoping to create clouds from that. So that's another way of doing it. And then the third way, and again, there's all these ways in between. This is not a complete list. The third way is to put sulfur particles in the stratosphere using airplanes, rockets, balloons, something like that, to get them way up high. Same thing that happens with a large volcano, Mount Pinatubo. Mount Pinatubo was the last example, where it cooled the Earth for a couple of years after it went. And then the fourth way is to put a solar shade between the sun and the Earth, and at the L1 point, which is where the gravity between the sun and the Earth cancels, so you can keep something stable there. It could be a huge mylar reflector of some kind, or balloons that are all attached together, and you need to block just 1 to 2% of the sunlight of the sun. So a little tiny, from Earth would be a tiny speck, sort of like a little dot on the sun, and that would lower, the sunlight hitting the earth and cool the earth. And that you could control and turn it off if you don't like it and all that kind of stuff. So there are different ways of doing it. So when we're talking about sulfur, it's kind of the one we know would work because that's what a volcano does. And it's also one that would work quickly. The space one would take a long time to develop and that kind of stuff. So that's why we kind of focus on that one. But I do want to make it clear there are other ways to do it. Yes, Brian, did you have something else? Because you raised your hand earlier. So
yeah, well, the second one that you mentioned is really just sea spray very close to the water level. And it's just like the sea spray that you get on any beach. It's a small size and of droplet. And those droplets form salt particles that seed clouds in the stratocumulus layer. That's the normal marine cloud layer that comes in to shore off California. But it turns out, the incidence of that has been decreasing according to the Big Bear Solar Observatory. And getting back to pre-industrial levels of those clouds would cool regions like coastal California substantially, back towards pre-industrial levels. So there's, it's nothing more complicated than sea spray. It doesn't require spraying it high up in the air because there's something called there are these cells, convection cells during the day that lift those particles up to the lifting condensation level, which is where the base of those stratocumulus clouds are located. And just regular convection does a good job of bringing those particles up to that height.
A few points are worth emphasizing right here. There was an article just yesterday that in the next 12 to 24 months, there's going to be mass coral reef mortality, and it's going to have, sweeping consequences for ocean ecology. We're kind of like we're tied to the chair and a toddler is playing with a revolver right now, essentially, in terms of ocean ecology. And the thing to understand about this is, solar radiation management, geoengineering, it's not just this human idea that a bunch of scientists and nerds think about. Marine life has been doing it for a long, long time. Coral reefs themselves do it, but the problem is that their ability to do it becomes impaired at higher sea surface temperatures. So this isn't even going out beyond what would be happening without us. This is just compensating for a fraction of the damage that we've done if we go and do the kind of level of solar radiation management which coral reefs and kelp forests have been doing for millennia. It's millions of years, actually.
Mm-hmm. Okay. By the way, let me say, if you have a comment or a question, now is a great time. If you raise your hand on Zoom, you go to reactions at the bottom of the screen and then click on that and then say raise hand. And Brian's raised hand again. So go
just
ahead.
Briefly, I'm wondering regarding that coral death, are there any articles you've seen recently talking about the coral death that's occurring other than the New York Times article from August, Eli?
So in terms of stuff that's being published, as you know, there's a lag. I haven't been following it as closely perhaps as I would have liked to, but no real scientific papers on that. But we know that it is happening at an unprecedented scale, and also in unprecedented ways where it wasn't just bleaching, but actually the animal cells dying. Which is not what we've been seeing before.
Yeah, no, actually, I do have a reference on that, and that is the grandfather of the Great Barrier Reef, Professor Ove Hoag Gullberg, did just publish an article I believe it was in Nature. He mentioned it in LinkedIn, and it actually talks about their studies looking at the reefs and watching those cells die. And that's exactly what they found on the first reef I ever visited, and that was the Sombrero Reef off Key Largo, was documented as dying in August and with those 101-degree temperatures. And to me, it was really tragic because that was the first reef I ever visited. I fell in love with the coral reefs, loved being down there, and really wanted to do more. And to think that, the first reef I ever visited is now dead, along with most of the other corals that are off of the Florida Keys, is really daunting. I mean, these ecosystems die silently. And, you got to read about it in the academic press half a year later. So it's a real concern.
And this is what a mega extinction now being driven more by climate disruption than simply changes in land use by humans. This is what it looks like, and there will be some headlines along the way, but a lot of it will just occur in the background because at some point it's no longer news. And we're very much the frog in boiling water who's just inured to it to the extent it even captures much attention. And
the fact that it's perfectly lined up with the IMO change in regulations is more than a coincidence.
Agree.
By the way, let's talk a little bit. I might end kind of early because again, I'm here taking care of my dad here, and my brother's coming in, and lots going on this end here. Plus, my computer, I don't have it plugged in this location. The battery's running down. But next week with Jim Hansen, again, he said he's going to do December 17th. It could always change, but but I'm expecting it to be next week. We're probably not going to have as much time as we had, for example, with Kevin Anderson, where we had like 3 hours of his time. I'm expecting about an hour with Jim. And I'm going to have some very specific questions for him. I want to cover a little bit of the pipeline paper. He has some messages he wants to deliver, so I'm going to make sure I ask some questions to do that. And then we'll have some time for questions. But what I'd like to do is if you're interested in asking Jim a question personally, or you just want me to ask him a question, if you could send a message to me, probably the best thing is climatechatclub@gmail.com, climatechatclub@gmail.com, and say, question for Jim Hansen. And also, if you want to ask it yourself, we're going to have the Zoom set up, and so I can invite you to the Zoom. The Zoom might be more restricted than it normally is, like for this kind of thing, because again, we're going to have just a limited time, going to be a little more structured in terms of like moving from subject to subject and things like that. So if anyone right here has a suggestion or something they want to ask Jim next week or something, or what area you want me to focus on, you can just raise your hand and we can talk about that right now. But otherwise, if Brian, if you're done, you can lower your hand. And if anyone else has a question or comment about, I'll do a quick summary of what we talked about. It was kind of long and rambling, but basically we were talking about the COP28 at the beginning, COP28, and the fact that they don't really take climate change seriously, and it takes different forms. One is that they elected a fossil fuel executive to be the leader of the COP28, which makes no sense whatsoever. But it also reflects the fact that the fossil fuel industry has infiltrated the COP process quite a bit. In fact, there's hundreds and hundreds of fossil fuel lobbyists and things like that at the conference. And that, again, the president is a fossil fuel person. That's one side of it. On the science side is that Jim Hansen and his colleagues have come up with new information that is based in science. And we didn't spend a lot of time today, but they have updated information on the last ice age that informs what the climate sensitivity is. We did the shipping experiment by decreasing their sulfur, and we can learn from that. He takes all of that, puts it together, and came up with the fact that both greenhouse gas warming is higher than the IPCC assumes, and aerosol cooling is higher than is more than what IPCC assumes. This has big implications for what they should be doing at COP, and yet they're ignoring Jim and his research. And we'll find out early next year whether Jim was right. If it warms up to 1.6, 1.7 C above the pre-industrial temperature in May of 2024, Jim was right. The other scientists won't have a good explanation of how it could be that warm. Nothing normal, nothing in the IPCC stuff explains that. And even the El Nino, this is not a like incredibly strong El Nino. It's a strong one, but like you have to have 2 or 3x El Nino or something to explain that much warming. So we're going to see that next week. So both from a political point of view, the IPCC isn't taking climate change seriously, and also from a scientific point of view, they're not taking in all of the research. I mean, a lot of research they do is very good. I gave a talk in 2008, basically, with a slide that says, this is why I said everyone says the IPCC is wrong. Those were the climate deniers. That I say they're wrong also, and because they're being too optimistic about what's happening. And that was in 2008. That, by the way, certainly ended up being true. I mean, if you take a look at what we've learned since 2008, even what the IPCC itself says is true since 2008, that information back then was way too optimistic. And so scientists don't like to, and we've discussed this best. The scientists don't like to talk about bad things. It's like, it's not a nice thing to do. So there's a lot of reticence in talking about how bad things could get. But it's important to talk about how bad things could get, because if you do that, then you can actually take steps to prevent it from happening. If you put your head in the sand and ignore what's happening, and it just happens anyway, it gets that bad, and you're just not prepared to do anything about it. So we do need to pay attention, and we do need to take action. And I think we will. By the way, I don't even know if I ever finished up on the solar radiation management or why we're going to definitely do it, within the next 10 years. And let's just finish that thought from long ago, is because when things get so bad that the public demands action, the only thing that will show results quickly is solar radiation management or sunlight reflection methods, because cutting emissions, which we will of course have to do, and maybe there'll be more impetus to do it then, won't show any difference in climate change for 20, 30 years. You won't be able to tell the difference the next year when you finally do it. I mean, you'll be able to tell you no longer, are using fossil fuels, you'll know that, but the climate won't change quickly when we cut our emissions quickly. I mean, at any level that, we cut them, if we totally cut them off, yeah, we might notice some things pretty soon, but it won't happen quickly. And all the bad stuff that the climate's doing that drove people to demand action will continue to happen, even if we use carbon capture too. That will also take decades to have an impact. But the only thing that has an impact in a year is solar radiation management. And that's why politicians will grasp for it. Because if they are actually going to respond to public demand for action, it's the only thing that people will actually notice happening. And that's why we're going to do it. And also, I mean, because people will really be fed up with the crap that will be happening, the shit that's hitting the fan, and will want to stop it. And so you can do something that stops it in 20, 30 years, and not even stop, but, lowers it in 20 to 30 years. Or you can do something that stops it in its tracks. And, I'm not saying there won't be side effects and other kinds of things happening, but it will work. And we know it works because it happens a few times a century naturally. And so we've seen it happen already. We can estimate how much sulfur that is and all that kind of stuff. And you can do those calculations. And Doug McMartin, who we interviewed, did that. Let's see, we have Bartosz. Bartosz, welcome. What's your question or comment? Not hearing you. You are unmuted, but I hear no sound.
Okay.
Oh, there you go. Now I heard something. Go ahead. Are you there?
Better? Yes, I am.
Not great, but go ahead. Let's see if we can hear you.
Okay, because I'm on my phone, so maybe
Okay.
now switched off the headphones. Okay, and I'm speaking directly to the phone. Okay. At first, I say it isn't my first this like climate track talk, but this is the first one in which I let's say gathered the strength to speak. And I have questions like to you specifically.
Okay.
Which is, well, I've read quite a few like communications and papers by Mr. Hansen. I'm not a climate scientist, but well, I'm doing PhD in telecommunications, so I can understand most of the math and some of the physics.
Okay.
But one thing I don't see clearly. Why do you treat these new findings about Mr. Hansen and his team, which, well, to me, they sound convincing. However, there's been like hundreds of papers written by thousands of researchers in previous years, which with varying ranges of this equilibrium climate sensitivities. So
Okay, that's a very good. It's a good question. I mean, I think, why believe Jim Hansen versus the thousands of other scientists, and even the ones that he mentioned, Michael Mann, Johann Rockström, and V. Kopp's father. That's a good, very good. It's a good question. Okay, can I answer that, or are you ready?
Yeah, sure. Yeah.
So first of all, I've known Jim for like 20 years or something like that, 15 or 20 years, and I've worked with him on different things. And the thing about Jim Hansen that is not true of the thousands of climate scientists out there is that he takes a look at the entire climate system. Many climate scientists look at microphysics of clouds, look at Antarctic ice shelves, look at ocean mixing. I mean, everyone is, most people are focused on specific things. They become an expert in that, and they write papers on that. And Jim takes all that information and he then synthesizes that into sort of the big picture, because he's been doing the big picture since he wrote the seminal paper on climate change in 1981 in Science magazine. And you can go back and read that thing and you'll realize he got it all right. Like, he predicted, it was back when people didn't know there was any climate change or even thought about it, really. And he said, this is the following things are going to happen by the year 2000. We're going to see the warming signal come out of the noise. I don't remember exactly the timing, but he said we're going to have the Northwest Passage is going to open up. We're going to have more rain in rainy places, more drought in dry places. He said all these things, and he was right. And he also, by the way, predicted the temperature, what it would be in the future. He got that right. So he's been right all along, right? And he's always sort of on the leading edge. He's the one who's not satisfied with the status quo, and he challenges that. And that's what he's doing right here. And again, why do I believe Jim Hansen? Jim Hansen's pipeline paper explains what we are seeing today. And all those other thousands of scientists can't explain it. Right? So if you believe the thousands, they don't have an explanation, not for a future prediction. He's also making future predictions. When will we see 2 degrees of warming, for example? He's saying it's earlier than what everyone else says. We'll see if he's right about that in the future. But what we are seeing today, the 1.5 C that we're seeing this year, no one else can explain it. So if you have someone who has, and also he's using good science, he explains his science. No scientist should ever just say, I believe this, and just says it, and then you're supposed to believe him. They have to provide the backup, the science behind what they say. And Jim Hansen does that. He does that by saying we have updated information on the last ice age, how cold it was in the ice age. And we know why, and he explains why and everything. He said, now, if it was that cold, and we know it was 100 parts per million less than pre-industrial, then we know that 100 ppm does this much of cooling. So therefore, we know a doubling of CO2 would cause this much warming. I mean, it's pretty straightforward, by the way. It's not even complicated. So he explains what we see. He provides good science to back it up. He's always been right, even when challenged. And he explains, even way before it shows up, like for example, sea level rise. It's very conservative what the IPCC says about sea level rise. But I think like 10 years ago, he wrote a paper. He's saying scientists are way too reticent about talking about how much sea level rise might really be, how much there might really be. And so far, we don't know if he's right on that one, but it looks like he probably will be right on that one as well. So anyway, that's a quick answer. I mean, he takes a look at the big picture. He uses good science. He's been right before. He takes, and those, Eli, maybe you have some.
Yeah, if I can add a couple of things. Emphasizing, he's talking not about predictions of models, but understanding, observations and measurements. Right. So you can argue about what causes what in what we've seen, but you can't really argue about what we've seen. And so that's one important strength of this paper. My other point relates to an exchange that I had with Z. Kosfather, one of the scientists he mentioned. And that was concerning, how long can the models be wrong before we actually have to reject them and say, yes, they no longer match the observations. And this is, the difference between the spread or the confidence interval in the model predictions versus the standard deviations of measurements we're observing averaged over time. And his answer was 15 years, right? So these models that the IPCC is relying on can be wrong for another 15 years before we definitively say, the models were wrong. Now, that's not the way you plan for future safety.
Right. Yeah. By the way, so yeah, I agree. So let's move on. But before I do that, I want to repeat again some upcoming guests we're having on this program. One is Jim Hansen himself next week, December 17th. All of these are on Sundays at 10 a.m. Pacific time. And if I'm a terrible YouTuber, I'm supposed to be telling you to hit subscribe and hit like and over there on YouTube Live if you're there. And please do. And even if you're not on YouTube Live, maybe you could go over to search for Climate Chat on YouTube. You'll get to our homepage. Click on any of the various things there and hit like and subscribe and hit notifications.
Smash that like button, Dan.
Smash that like button.
That like button.
Yeah, we're not, by the way, we're not anywhere close to where we should be. And well, we're starting over again, really, going to YouTube Live. We had 8,000 followers on Clubhouse, but that all kind of went away when they just screwed up all that stuff. So we're starting again on YouTube, and hopefully with Jim Hansen coming, we'll get a lot of coverage. And again, the good news is you don't have to be live on it. If you're doing something next Sunday morning and miss Jim Hansen, you'll be able to go to our YouTube page, and just like pretty soon after the show ends, it will be up there as a replay, and you'll be able to listen to it. So that's the good news about being on YouTube Live. Jim Hansen, December 17th, Peter Ditlevsen on January 7th, he co-wrote the paper on the AMOC collapse being expected. It's not exactly the word he used, but warning of a AMOC collapse in around mid-century. That's sort of the title, something like that, which is really mind-blowing, by the way. that could happen. And Jim Hansen also agrees. We'll probably ask him something about that next week. Even before this paper came out from Peter, Jim Hansen was talking about, and he mentioned in a previous paper quite a few years ago called the ice melt paper, that the fresh water coming from the melting Greenland could go into the North Atlantic and slow down and stop the AMOC. Keep yourself muted, by the way, if you're not asking a question. And so anyway, so that's January 7th, and January 14th is Johanna Volhart, who's a researcher doing work on how protests can change social policy and things like that. And we'll be obviously focused on how climate protests can do that. She looks more broadly, but she told me that she's going to be at a conference the week before on climate protests. And so she might have some good insights onto that as well. So that's a hard-hitting upcoming interview list. And if you have suggestions for people to interview, and by the way, if you know people at Mirror, we should do one on Mirror, the mirror reflection thing. Write to me at climatechatclub@gmail.com, climatechatclub@gmail.com. You can also find me on Twitter at Dan Miller 999. Clubhouse, the same thing. I probably should be on some more platforms and stuff like that, but that's enough for now.
And just a
yes.
reminder, I dropped in the chat the link to the notes so any of the articles, papers, whatever that were discussed today, and the upcoming speakers and their links to their papers and whatever is there.
Is that the automatic AI thing that's generated?
No, this is
Which is pretty amazing, by the way. I'll just say Zoom has an AI engine that if you have a regular meeting forget climate change, you're having a business meeting and you turn that thing on, it's as if there's a note taker in the room writing down what everyone says. And it's actually pretty eerie thing. It's using real AI to do it.
Yeah. So, I mean, and if you wanted to give me those, I could put them in here as well. I've just been trying to keep
I don't know what to do with those yet, but I'm reading them and it's like, yeah.
Well,
and
no,
then it
it's
says,
more just like,
and then Stacy said she has a log to reference of it. It's that kind of thing.
Oh yeah, no. It is not this is not note taking. This is just the stuff that people have put out.
The links and everything.
Papers that you're talking about, the guest, whomever is it. And
we can put some of that, by the way. I do put some of that into the notes on YouTube, which is a place to put that stuff too. And I put the Jim Hansen page. Yeah. So we'll have to follow up with that. Well, where were we? So we're on these. If you have suggestions for topics, I mentioned if you have questions for Jim Hansen, you would like me to ask him next week. We're going to have very limited audience questions because of the time frame. It's going to be very limited. But if you really you want to be one of the people to ask him a question, then please write to me, climatechatclub@gmail.com. Okay, so we got that YouTube and stuff, upcoming guests out of the way. Nadia, welcome to Climate Chat. What's your question or comment?
Oh, hello. I guess I was hoping to get some kind of idea of the human cost of all the additional climate change. As well, I don't think people kind of grasp the stakes of the additional warming in general.
Mm-hmm. That's a very good question. Probably deserves a whole room, and I think we've covered aspects of this before. But there is a big debate. I don't know if it's a word, but discussion about whether the future climate change hitting 2 degrees or so will kill 1 billion people or more. And there's some people that say, no way, it'll kill 1 billion people, that kind of thing. Only be hundreds of millions. But so I think it's an open question that deserves a lot more research. If you ask me, I would say, yes, that is very possible. And it's not because you would say, when temperatures get to X, 2 or 2C warming, then you can then show that extreme heating in certain parts of the world become unlivable for people to be outside for more than a couple hours or something like that. And then you can kind of calculate the deaths and everything. Yeah, and if you do that, you'll come up with some number, and it'll be kind of impressive number, but it won't be billions of people. The problem is not the single direct causes. It's the combination of causes. So that kind of heat causes breakdown of the food supply. And the breakdown of the food supply causes famine. Famine causes lots of deaths, number one, but it also then leads to war because some place has water and food and another place doesn't have water and food. And this always happens when people are faced with lacks of resources. In fact, there's an MIT study. It was a very simple study. It just showed the UN global price of food versus riots around the world for any reason. And it showed whenever there's a huge spike in food prices because of a shortage of food caused by climate change, for example, that was the one they showed. Then you had the Arab Spring. The Arab Spring came out of a drought in Russia that caused them, it was really exceptional drought, that caused them to shut off grain supplies outside of Russia. They wanted to keep the grain for their own people because they had a shortage. They wanted to make sure they had enough food for themselves, and therefore they shut off grain supplies to the rest of the world, which caused food prices to shoot up everywhere. And okay, if you're in the United States and eggs now cost $6 instead of $3, okay, yeah, you can complain about it. But if you're spending, 40% of your income on food and prices triple, you can't deal with that. That's not something you can't, it's just not the same thing. And therefore that causes social instability and riots and things like that. And so it's not the single things that I'm worried about. It's the climate impacts interacting with the human social systems, and then all of them sort of interacting and then things collapsing. And that could actually happen. We saw what happened when there was a shutdown of subprime mortgages, something that no one even heard about before it happened. Like, who knew about what a subprime mortgage was before 2008? But then they collapsed and they caused a worldwide recession for something we never heard about. Like, it was taking a little card out of a house of cards and part of it collapsed. Now with climate change, we'll be pulling cards left and right out of that house of cards. And we don't know what's going to happen. It's really hard to study that. So that's why I'm concerned.
Also, like during the financial collapse, nobody outside of the financialization world would have thought it was even remotely sane to let people get insurance against their bad bets, right? Which is what drove that. And we're sort of doing the same thing by hiding, the true extent of the risks that we're facing with climate change.
Mm-hmm. Good. So Nadia, did that help answer your question, or anything else? Or okay.
Well,
yeah.
I think the scientific basis of an answer might be like the old NASA estimates that the amount of arable land would be reduced to only enough to support 400 million people. So So
one of the things that could happen, and we had a whole show on it here with Matthew England, I remember, who did a study on what happens if the AMOC, if the Atlantic Meridional Overturning Circulation, the Atlantic Ocean conveyor belt shuts down. And he showed that, you can get like a foot less of rainfall over the entire Northern Hemisphere, which is, blow your mind, right? That means agriculture productivity. The one place when I looked this up, the one study for a particular country was UK, and they showed that it would drop UK arable land by 2/3 would disappear. 2/3 would disappear if you had an AMOC shutdown. And an AMOC shutdown is expected. It's not like might happen sometime this century. There's a small chance it might happen. Is expected to happen, according to this recent research. And listen on January 7th when we interview the researcher on this. And so if an AMOC collapse happens, shit is hitting the fan right and left. And by the way, none of the IPCC stuff, none of this stuff you're hearing about, oh, it's going to get so warm, this is going to happen. None of it assumes an AMOC collapse. An AMOC collapse is, like, I call it the mother of all tipping points for the near term. You can come up with some really bad ones in the future. But, things like one that we probably passed already, the West Antarctic ice shelf collapses. It's gone. I mean, we're not getting that back. We waited, way too long. There's some research that said it happened sometime in the last 80 years, let alone the last 10. But that's going to cause sea level rise of 10 feet plus just for that one little thing that's happening. And that we can't stop. But that's 10 feet over maybe a few hundred years, and we can move, okay? We can adjust over some timeframes for sea level rise. So even though that's a tipping point, it doesn't cause shit to hit the fan all over the world at the same time. An AMOC collapse just does that. It just screws everybody kind of simultaneously. And so anyway, so it's an open question. Certainly one that's not researched well. To the extent it is researched, it says warming will cause a coral collapse, coral reef collapse of this much, or warming of this much will cause extreme temperatures in these places that will be very difficult for humans to survive. if they're outside without air conditioning. Yes, and those things they're not wrong. I mean, and it's very useful, but it's not a tipping point that throws everything out of whack simultaneously. Temperatures, rainfall, sea level rise acceleration, storms we've never seen before in the history of humanity, stronger than anything we've ever seen. These are things that will all be happening like simultaneously. So we'll be trying to deal with the lower rainfall and the fact that, England can't grow food anymore, or whatever. And okay, if that was the only problem you were dealing with, that would be very difficult to deal with. But okay, you can still. But at the same time, England, by the way, will be getting freezing cold because all of a sudden the warming currents are gone. Sweden dropping like I think it was Norway or Sweden dropping like 8°C. We're talking about 2°C of warming being a global catastrophe, right? 2°C. And now your country drops 8°C. I mean,
well, and also all that heat stays in the tropics, near the equator,
or near the Antarctica.
Makes much of ultimately makes much of Central Africa uninhabitable, and
helps collapse the Amazon, right? So even just the Amazon collapsing, which, by the way, might happen all on its own without an AMOC collapse. Just that's where we're heading. We're through not just because of climate change, but because of deforestation. And the Amazon generates its own weather. It generates its own rainfall. So if you destroy enough of it with deforestation, it will stop generating as much rainfall, which will then stop it from growing as many trees, which will have less rainfall. It gets into its own little loop, right? Well, on top of that, we have climate change.
The Amazon's already having sandstorms.
The signs are all over the place. By the way, it's a rainforest and it's having these mega droughts. You're not supposed to have mega droughts in a rainforest, right? So, yeah. So anyway, yeah. So my point is, we're not. Well, COP28 is not taking climate change seriously. That's the subject of this room. The world as a whole is not taking climate change seriously. How do we know? Well, there are no serious policies in place to fight climate change. Period. I mean, there are some good examples in some countries doing some good things and agreeing to phase out fossil fuels in certain places at certain timeframes. But we're not taking this seriously. We're not.
Well, not just
not yet, at least. I think it'll change if shit hits the fan. Yeah, go ahead, Eli.
Not just that, but by policy in terms of bans on SRM and people trying to prevent research being done on it. It's like we're taking the most powerful, fastest acting, most economical tool off the table.
Yeah. Well, again, I think that's going to change. I mean, right now, people, I would say the public doesn't know anything about SRM one way or the other. They never heard about it. They don't know about it. When they demand action, which they haven't done yet, but just wait, wait 5 years. It's going to be a very different world in 5 years. When they demand action, and then they say, well, the politicians, well, there's this one thing we could do that would work right away. What is it? What is it? Tell us. And they say, well, it might have some negative things. I don't care. Because we know what it's like now. This is unacceptable. So let's do something else. And so I think that will change quickly, actually. Or how does it go? The phrase is, we'll go from impossible to inevitable without ever passing through possible when it comes to that kind of thing. So we'll see. Brian, I think you had something else you wanted to say. Then I see my battery draining rapidly here without a power source in this room. Go ahead.
Sure. Yeah. You mentioned the sea level rise, and I just wanted to mention briefly that the Earth system's already demonstrated about 10 feet of sea level rise on century timescales during the last interglacial. So there's no reason to expect it to be different this time. I mean, during that last example, greenhouse gases were at 280 parts per million, and now we're at 500 if you include methane and other greenhouse gases like nitrous oxide.
I think the important thing to know about the Ice Age is, okay, pre-industrial CO2 was 280. In the Ice Age, only 18,000 years ago, by the way, not like millions, it was 18,000 years ago. humans were alive. Humans were roaming the planet. 18,000 years ago, it was 100 parts per million less than pre-industrial. It was 180 parts per million. It was 100 parts per million less of CO2, and sea levels were 400 feet lower than they are now. 400 feet. Florida was 3 times wider than it is now. You could walk from Russia to Alaska, which is why animals and people came that way. And that was only 100 parts per million less than pre-industrial. We are now at 140 higher than pre-industrial. Now, it's not one-to-one because cutting something in half, versus doubling, CO2 is logarithmic. So going from 100 to 200 is the same as going from 200 to 400. Okay, but in terms of it's doubling, but still 140 is a lot. And
we've done it. I mean, we're effective greenhouse gas levels above 500. But I did have a question.
We're at a doubling right now. Yeah.
Mm-hmm. Why don't groups like the Nature Conservancy and the Sierra Club bring lawsuits against the IMO for killing the coral reef off the Florida Keys?
Yeah, of course. Yeah. I was at one of the very first meetings with the Sierra Club when we were talking to them about, by the way, guys, you better pay attention to climate change. Because up until then, this is a very long time ago, by the way, 20 something years ago, but it was, the thing was owls in the woods and conservation of nature and, that kind of thing, stopping, deforestation with things. But we were saying, hey guys, climate, there won't be, I remember I said this at the meeting, guys, there won't be any more owls in the woods if you don't address climate change. And it's very difficult for them. Sierra Club's an interesting thing because it's, you could think of it as they have 1 million members and there's like a million separate ideas of what to do. And so it's not as tight it's a difficult thing for them to turn that ship, which they did do. I mean, they did get pretty serious about climate change. And they fought coal, which was their big campaign. Unfortunately, it switched to natural gas for the most part, and they thought they were making good progress, but natural gas turns out to be as bad as coal when it comes to climate change. Not for human health, it's much better for human health, but in terms of climate change, we're getting rid of coal and we're all feeling good about it. Coal is terrible stuff. It's absolutely horrible from every angle. Climate change, human health, mercury in fish. I mean, you can just go on. It's horrible. We should get rid of it. But replacing it with natural gas is not a good thing to do when it comes to climate change. You need to replace it with renewables, things that don't give off methane or CO2.
Oh my gosh.
We're jumping all around. Go ahead.
No, but you just, that sort of comparison and the transition it reminds me, you could take out coal and put in gas powered cars, and you could take it and then you could put EVs in for the natural gas. This is better. Yes, totally better. But it still is not quite, a train, a bus, an e-bike.
Well, you got to get rid of. Well, okay, yeah, that's true. There's a lot of things we need to do, and we're running out of time. Again, the good news, well, running for the show and also for climate. I do think, how can you keep talking about this stuff without getting like incredibly depressed? Which is a good question. But I do think that we're not really serious about climate change yet. The only thing I've seen in 20 years of doing this stuff that works is the fact that climate damage gets people to pay attention when they understand that it's due to climate change. That is very new. It's only the last few years that the public is aware that the damage they're seeing on a daily basis is actually caused by climate change and not just a random fluctuation of the weather. And that is going to happen much more in spades you think the last 5 years was that, wait to see the next 5 years and the 5 years after that. So there really won't, it's hard to predict what's going to happen based on the past, because the future will not be like the past. And so we will be coming up with climate policies in a totally different environment than we have in the past. where disinformation, where, and I had a whole set of things to talk about because of what these fossil fuel, the head of the COP meeting was a fossil fuel executive. What is some of the techniques he uses to deflect away from, the big problem, which is fossil fuels, and misdirection, blaming another, a lot of things. Calling it alarmist is a great thing, right? That's one. Alarmism is not scientific. Don't be if this person's alarmist saying that terrible things are going to happen, then obviously they're not being scientific, and that's some of the techniques they use. But that's going to go out the window when the shit's hitting the fan, your personal fan, right? And not just some far off place in Bangladesh. So we're going to see more and more of that. And I do think that will, and that gives me hope. It's kind of unfortunate that that's going to happen, but it would be even more unfortunate if that would happen. And that means when we continue to do absolutely nothing. So I think we will try to do something, in the next decade. And when we do, and as we talked about here, we do have tools available. Now, we should be doing a lot of research right now so we can scale them up as quickly as possible when the time comes that we finally decide to do something. By the way, what I'm telling you is, by the way, very much like what Jim Hansen says, because he's been doing this since 1981, right? He thought when he testified in Congress, he said, by the way, there's going to be a huge problem if you don't do something right away. And back in 1988, when he testified, we could have started reducing fossil fuels by, 1% a year, and it would have been totally fine today. But now we have to do 10% a year, and it's impossible to do. And he realizes now, he realizes he was naive. He was a scientist. You explain the science, you explain your rational argument, you explain what's going to happen if you don't do this. People realize that's a terrible thing that's going to happen if we don't do that. We better go do that. Absolutely didn't happen like that. Absolutely didn't happen. And so you can see in his writing today, he says things like, well, when we finally decide to do something, this is what we'll do. He's not even calling for people to do it today. I mean, he's saying, by the way, he's in his current paper, he's saying we have very little time to act. He's saying that now. Like, this is the decade we have to take action. But he's also saying, when we decide to act, that's when we'll do these things. Because he realizes that, we're not being rational at all, by the way. This is totally irrational reaction to the situation we're in. Yes, Nadia, do you have something else you want to say?
Yeah, as I understand it, I think there are Pacific Island nations already either in the process of evacuating or making treaties to basically evacuate their entire populations to, I think, mostly Australia right now. So
Australia, New Zealand, yep, that's happening. That's true. Especially low lying, like Palau and stuff like that. I mean, these places are, the
Atlantis
Maldives,
waiting to happen.
The Maldives. You better go enjoy it now if you want.
Yeah.
It's telling me your Mac will sleep soon unless plugged into a power outlet. I think that's a sign. So let's just finish up. We have Stephanie. What's your question or comment? Welcome. Good to see you.
Hi there. Good to see you. I put my question in the chat, but I'm just wondering, could you define what the word unabated is?
Sure.
That the petrostates, because they keep using this word, and every time I read about it, it has a vague definition. So what
they mean to abate is to offset. So if you're burning fossil fuels and then you have carbon capture, let's say out of the air. I'll give you a really simple example. Aviation. Now you can argue that there's biofuels you could use that would have a low carbon footprint, but it's questionable, and they have land impacts if you do that. So putting that aside, let's just say you were going to burn fossil fuels. You're going to jet fuel for the next 30 years because hydrogen planes are too far off in the future. So one thing you could do, and I actually think would be a good idea, is to scale up direct air capture and offset that. It would be currently about $5 a gallon at today's prices of direct air capture to offset every gallon burned. But and by the end of the decade, that might be $1.50, which would be a pretty reasonable charge, versus the other things that even hydrogen could be expensive and all this stuff. So that would be a way of abating the impact of the aviation emissions. You abate it, you counter it. Now, if you're really planning on, I actually don't mind doing that. The problem is the fossil fuel companies just want to talk about it without actually doing it. Go make them pay to abate every gallon they burn. With whatever technology, and it has to be certified, right? It has to not be crazy like planting trees. It has to be, you took a ton out of the atmosphere, you put it back underground. Right now, that's $500 a ton. Might be $100 a ton the end of the decade if we're really good. But at when they tell you, oh, we'll use carbon capture, you say, great, we're going to pass a policy that requires you to do that. Not just talking about someday you'll do it. You're going to do it starting now. That is effectively a tax on fossil fuels of, again, $5 a gallon to start with, which is very high. But again, about $1 a gallon would probably, over time, actually take care of the problem. And so if the fossil fuel companies are going to claim they want to do that, great. That's a wonderful idea. Let's do it. Let's start a phase in. You got to maybe pay half of it next year, or 25% of it next year, then 50, 75. Then 4 years from now, you're paying 100% of what it takes to get rid of every gallon that you burn, and then see what they say. By the way, they might say, they might even agree, but what will end up happening is you will get rid of fossil fuels because it is clearly cheaper to replace the fossil fuels with renewable energy than to pay for the fossil fuels and the cost of carbon capture to get rid of it.
Yeah.
Right? That's really clear.
Unabated. They're saying unabated. So they don't even
So
want
unabated are emissions that don't have that you're not taking care of. You're not offsetting.
So they
That
won't,
would be a coal power plant. You're not. It would be really stupid.
Just to simplify it, they won't say we need to get rid of this stuff. So what they say is we need to abate the use of this stuff. That's what they're doing.
Well, another example would be, by the way, a cement plant that has carbon capture on it, and you can capture 90% of the emissions. By the way, not all those emissions are from fossil fuels. Some of it's just the chemical reaction of cement is half of those emissions. But you could say that that's an abated use of fossil fuels. It's made 90% abated, so there's still 10% you'd have to address otherwise. So that's abated. Again, I'm actually really not against that, even though a lot of people are. I'm not against it if you force them to really do it, as opposed to talk about doing it in order to continue what they're doing, which is to burn fossil fuels with no restrictions, without any taxes, without any requirement to get rid of it, right? What would it be like? It'd be like saying, telling, I don't know, the bottling, the sodas, yes, it's a big pollution problem to have aluminum cans or plastic water bottles, right? So we're going to have policies about unabated plastic bottles. Now we're not going to do anything ourselves about it. We're just going to talk about it so we can continue making plastic bottles, right? It'd be kind of like that. But if you made them recycle every bottle that they made, then you say, okay, great, now go do that. Here's a
which,
law,
by the way, used to be the
law
case.
that says you have to do it. What?
By the way, that used to be the case long ago. Glass bottles recycled.
Yeah, that's true.
Or cartons for water.
When I was a kid, the milkman delivered the milk into a little cooler
Glass jars.
chest in your back door, and then you took the empty bottles, you put it in there, he took them back, and that's when I was a kid. Let's see. I think Nadia had maybe one more question. Then we're going to call it quits as my battery gets getting very low. Nadia, what's your last comment?
Well, I think
maybe you didn't lower your hand. That could be that too.
That was the case. Although I do have a comment. I guess aviation fuel will probably have to be like synthesized from doing Fischer-Tropsch on atmospheric carbon dioxide or
we could do that. That's another way to do it.
Yeah, because
that's another way to do it, but that's also expensive. By the way, that you're kind of doing carbon capture to do that too. So
Yes.
That's
Well,
another
does
way
the
to do
carbon
it.
capture up front. That's the point, because if you don't do it up
And I do
front,
think
you'll
that
find a
that's
way to get out of it on the back
it's
end.
very expensive right now, but that actually will get cheaper over time. As hydrogen gets cheaper over this decade and carbon capture gets cheaper over this decade, making synthetic fuel from atmospheric CO2 is something that actually is doable today. It uses technology from 50 years ago, but it's doable today. It's expensive, but it will get cheaper over time.
And,
With
and
that,
there are electrochemical routes.
and there's other ways to do it too.
Yeah,
That's true. So with that, thank everyone for coming. Again, a reminder, next week, Jim Hansen. All of these are Sunday at 10 a.m. Pacific time. Jim Hansen, December 17th. Don't miss that. January 7th, Peter Ditlevsen, wrote the AMOC collapse paper. And January 14th, Johanna Volhart, who we're going to discuss protests in general, but climate protests and how effective they could be. So thanks with that. And Brian, do you have something very short to say?
Yeah, it's just that Alfie does a pretty darn good job of capturing that that carbon, and the Department of Energy came up with hydrothermal liquefaction as a great way to turn it into biocrude. So that could be,
there's
you know,
a lot of
alternative
different
way to get
choices
there.
out there. Yeah, a lot of different choices. And if we put policies in place that actually require, people to do something, then that's the way to go. And okay. Why do you have LMT? What does that stand for?
Oh, sorry, that's Eric here. Sorry about that.
I know, but I don't know what LMT stands for, but go ahead, Eric.
Sorry I missed today's meeting. If you already talked about this, then I apologize. But this release of this amazing letter from OPEC to OPEC.
No, didn't see that. We didn't talk about that. Maybe we're not going to talk about it next week because Jim Hansen's on.
Yeah,
but maybe after that.
I'd love to talk about what do you learn when you see the internal communication. How do we leverage that? It's like having the war plans of the Nazis. There should be a good thing to make use of it. Thanks. We're going to be clever about how we use it. Thanks.
So smash that like button, subscribe to the YouTube Live. Even if you're listening on Zoom or Clubhouse, go over to YouTube, search for Climate Chat Club, go subscribe, like some of the videos there. And we will see you next week with Jim Hansen. Again, if you have questions for Jim, please email me at climatechatclub@gmail.com with your suggested question. I'm not sure we're going to really get to have too many live questions because of the limited time we're going to have next week. So see you then. Thanks for coming, everybody. And we'll see you next time. Bye-bye.
Bye.